Good morning, everybody. Today we will discuss the next nucleophilic aromatic substitution reaction, that is the Benzyne mechanism. In the last class we have discussed the addition elimination reaction, that is SNAR mechanism, and we know that there are four different type of nucleophilic aromatic substitution. First one is addition elimination reaction, which is otherwise known as SNAR mechanism, that we discussed in the last class. Today we will discuss the Benzyne mechanism, the next second mechanism in nucleophilic aromatic substitution reaction. So the Benzyne mechanism is otherwise known as elimination addition reaction, and this type of the mechanism occurs in aryl halide, and for the reaction strong base is required for the reaction. An incoming group does always take the position vacated by the leaving group. These are the basic features for the Benzyne mechanism. Now we are moving into the reaction. First of all, our starting material is the bromobenzene, and strong base NH2 minus will pick out one of the hydrogen, which is the most acidic hydrogen and which is situated ortho to the leaving group bromine. Our first step is the elimination reaction. Then due to this a carboanion is generated, and this carboanion pushes the liberation of the bromine as Br minus ion, and an intermediate benzyne is formed in the elimination step. And we know that the benzyne intermediate means it is a triply bonded the benzene ring, and here I have shown in the yellow box. Here a sigma bond is there and 2 pi bond is formed, and 1 pi bond is formed by the sidewise overlap of the p orbital, which is perpendicular to the plane of the benzene ring, and the next pi bond is formed by the overlapping of the p orbital, which is in the plane of the benzene ring. Since each carbon atom, the triply bonded bonding is very difficult in the benzene ring, so that's why the benzyne intermediate is very reactive. So it will easily attacked by the NH2 minus base which is present in the reaction medium, and we will get a carbanion, and this carbanion is attacked by the ammonia which is present in the reaction medium, and we will get aniline as the product. And one of the speciality of the Benzyne mechanism is that it is a cine mechanism. Then we are moving into the another example. So here the starting material is chlorobenzene. So the mechanism is very similar to the previous one, but here we used the base as a sodium hydroxide, and the sodium hydroxide remove the hydrogen which is adjacent to the leaving group chlorine, and an benzyne intermediate is formed, and this benzyne intermediate is formed by the overlapping of the two set of p orbital, and it is very reactive. It undergo the addition reaction, and we will get the final product. Okay, so now we are moving into the exceptional case of the benzyne intermediate. The regiochemistry or regioselectivity. We have already studied the definition of the regioselectivity. Regioselectivity means where the reagent will attack. Okay. Now regioselective reaction means in this reaction reagent can attack more than one way to the starting material, and the substituent, and we will get more than one product in regioselective reaction. So here also the base is a sodium NaNH2 is the base, and it will pick out the most acidic proton, and here the most acidic proton is the hydrogen, which is very close to the bromine, and it will form the benzyne intermediate. In the benzyne intermediate is very reactive, so the base NH2 minus can attack the benzyne intermediate either through the right hand side of the methyl group or through the para position of the methyl group. If it is attacked in the ortho position, we will get A as a product. So the carbanion is generated in the meta to the methyl group. If it is attacked in the position B, the carbanion is generated in between the CH3 and NH2. So in product B, the carbanion in the benzyne intermediate is formed in between the CH3 and NH2. It is really unstable. So that's why the product A is the major product. Now we are moving into the another example. So here in this example, the specialty is that one of the electron donating group is attached in the aromatic aryl halide. So that's why we have two position for the attack of a nucleophile in the addition reaction. Now we are moving into the another example, that is the para-chlorotoluene. So in the para-chlorotoluene, the methyl group electron donating group, which is para to the leaving group chlorine. So first step is the attack of the strong base, and which will pick out the strong acidic hydrogen in the ring. So we know that the hydrogen which is more acidic is the hydrogen which is ortho to the leaving group chlorine. So it will pick out the hydrogen which is ortho to the chlorine, and we will get the benzyne intermediate is like this. Then there are two possibilities for the attack of the base NH2 minus, either from this side or in the bottom of the slide. I have shown the second possibility. So this way or this way. If it is attacked in the top, it's just like in the top phase, we can see that a carbanion is formed which is para to the methyl group, and we know that the methyl group is electron donating group. That's why the next addition will occurs in the para position. So we will get a methyl aniline as the product. And whereas if the NH2 attack in the para to the methyl group, we will get a para-methyl aniline as the product. Now we are moving into the another category, that is if the already substituted group is an electron withdrawing group, then what will happen? I have shown the starting material in the red color. So this is the starting material in which an electron withdrawing group is attached, and our leaving group is the chlorine. So first step is the strong base will attack the most acidic proton. Here I have shown the hydrogen most acidic proton as red color, so which is situated in between the leaving group chlorine and electron withdrawing group. So that hydrogen is picked out by the most stronger base, and we will get a benzyne intermediate. Okay, then after that, so the probability for the benzyne intermediate is the benzyne intermediate which I have shown in the bottom of the slide. And there is another possibility for the benzyne intermediate which I have shown in the top of the slide, but more possibility for the bottom of the slide, because most acidic proton is the hydrogen which is in between the leaving group chlorine and electron withdrawing group. So the benzyne intermediate which I have shown in the bottom of the slide is the most preferred benzyne intermediate. Okay, so first of all we will discuss that intermediate first. Please see the bottom of the slide. So after the generation of the benzyne intermediate, the nucleophile can attack from both sides of this benzyne intermediate. If it is attacked to the meta position, the carbanion is generated in the ortho position, and that is the favored condition because here the carbanion is very much closer to the electron withdrawing group. That's why this carbanion is more stable. Okay, so whereas the other possibility is the NH2 group is attacked in the ortho position, so the carbanion is generated in the meta position. Since the carbanion is away from the electron withdrawing group, that is a disfavored carbanion. Now we are moving into the top of the slide. Here also a benzyne intermediate is formed, but most preferred, this is a most disfavored benzyne intermediate, because this benzyne intermediate is formed by the picking out of the hydrogen which is less acidic. That's why it is not preferred benzyne intermediate. Okay. Now we are moving into the some of the important point which we have to give the more importance. First is in the benzyne mechanism, means it is an elimination addition reaction in which we are using the most strong base as a starting material, and the most strong base will pick out the most acidic hydrogen, and this hydrogen is always located ortho position to the leaving group halogen, and during the elimination reaction an benzyne intermediate is formed, and benzyne intermediate is triply bonded benzene ring, and it is highly unstable and most reactive. And in the next step, that is the addition step, due to the attack of a nucleophile, a carbanion is generated, and this carbanion will pick out the H plus ion in the reaction medium, and the substitution will occur. One of the speciality of the substitution reaction is it is a cine substitution. I hope that you understood the concept. Thank you.